Ahoy mateys, and welcome to a new tutorial. In this tutorial I'm going to show you how to make a GUN4IR build from the ground up. It's about time. Special thanks to JB for providing this wonderful tech to the world, and Raymond over at RPEG Electronics for helping me on the journey to creating my GUN4IR builds. Before we get started, you'll need to download the GUN4IR GUI, see link below. Let's start with the IR LED sensors. Going to need a PCB board, 4 27 ohm resistors, 12 IR LEDs, a USB 2.0 A-type male power plug, a DC female power jack, and some electrical wire. See links below. Let's cut a 5x6 set of holes out of our PCB board. We'll need to create 4 pieces. Now when inserting your IR LEDs, you'll need to have the long legs on the left hand side when installing. Do this for all 3 IR LEDs. Now we need to pull the IR LEDs out about 1/2 inch. Don't have steady hands like Raymond. This could be a little tricky, so take your time. Then bend the LEDs back to lock them into place. Let's solder all 6 points. When this is complete, bend the far right lead up. Should look like this. Now we can install the resistor. It will need to go into this location. Make sure to leave some room to be able to bend the resistors to this side of the PCB board. Should look like this. When complete, bend the leads back to lock them in place. Now we need to bend the IR LEDs to the correct position. The first pin needs to be straight down. Pin 2 and 3 need to be crossed over to each other. Pin 4 and 5 also need to be crossed over to each other. Should look like this. Let's solder each point. Make sure to connect the resistor lead to the IR LED lead with some solder. When soldering the crossover pins, just apply some solder between each lead. Should look like this. Cut the excess leads off. Need to repeat this process 3 more times to complete all 4 IR LED sensors. Now we can cut some wires for the length of your TV. We'll need 4 sets of wire, 2 for the left and right and 2 for the top and bottom. For example, if you have a 32-inch TV monitor, you will need two 20-inch long cables for the horizontal and two 12-inch cables for the vertical. It's okay if you give yourself some extra wire for each end. After cutting your wires, trim off about an inch for each side. We can always cut the wires if we have excess. For one side of your wires, twist the red wires together. Do the same for the black wires. Should look like this. Now for the DC power jack, we will need to trim off the ends and remove some cable shielding. Trim off about an inch from each end. Now twist the wires onto the set of wires we just twisted, red to red, black to black. Should look like this. Let's put some solder on each set of wires. You can either use electrical tape or shrink tubing to the ends of each wire. Now we can attach each wire end to the IR LED sensor we created. To make it easier, put some solder on each wire first. Then solder each wire to the board. Should look like this when complete. Do the same for each IR LED sensor. When everything is complete, we can test out the IR LED sensors. Plug in the USB power cord into the power jack and then into the power brick. You can use any phone charging brick you have lying around. Now when testing the IR LED sensors, just turn on your camera on your phone and take a look. You should see a purple light emitting from each LED. I guess some Apple phone cameras cannot see infrared, so use an Android phone. When you confirm that all the IR LED lights are working, you can place Velcro onto each board and place them onto your TV. Run the calibration tool inside the GUN4IR GUI for the correct placement of each sensor. In the next few steps, I'm going to show you how to build all the internal components before placing each one into your gun. Let's start building the recoil portion of the build. In this build, you will need one IRL 540N MOSFET, a Pro Micro Arduino board, PCB board, one 100K ohm resistor, one 1K ohm resistor, one N401 diode, a solenoid, one extension cord, a power supply, and at least a 10-foot micro USB cable. See links below. Let's start with cutting a 3x6 set of pinholes for the piece of PCB board. Should look like this. Now let's install the MOSFET into the top 3 pinholes. Bend the leads at this point. Solder all 3 points. Clip the extra leads when complete. Should look like this. Now we can install the 100K ohm resistor into this location. When complete, we can bend the leads back to lock them in place. Let's install the 1K ohm resistor into this location. Bend the leads back when complete. Let's also install the diode. Make sure that the gray bar is facing down when installing your diode. Install into this location. Bend leads back when complete. This is what it should look like. Flip it over and solder all the points except this point. We are going to leave this pinhole open for a wire we are going to install later. Clip the leads when complete. Should look like this. Now let's cut 2 pieces of wire for your ground wires. Depending on what your gun setup is, measure out what you think you need for the length of your wires. Strip both ends. Install each wire into this location. Let's cut 3 more wires and strip the ends for each. See diagram for the install location. You can either use the same color combination or whatever wire you might have lying around. Solder each point. Clip the leads when complete. Should look like this. Cut another wire and strip the ends. Going to solder this wire onto the back of the PCB board in this location. Now solder these points together. See diagram. Should look like this when complete. Going to solder my green wire to the 7-pin hole in the Arduino board. This is the recoil pinhole. Cut the lead when done. Now let's solder the first ground wire to the ground pinhole location on the Arduino board. Cut the lead when done. Should look like this. Pull out your extension cord and cut the male end off. Remove some cable shielding. And trim the ends off for the red and black wire. Take the other ground wire and splice both pairs together. Do the same for the red wires. Solder each wire. Either use tube shrink wrap or electrical tape on both wires. Now it's time to wire your solenoid. For my wire combination, it's my 2 yellow wires. Twist each wire together. Doesn't matter which one goes to each other. Solder both wires and then wrap in shrink tubing or electrical tape. Make sure to wrap everything together either with electrical tape or shrink tubing. Now it's time to test everything out. Plug in your micro USB cable into the Arduino board. Or make sure not to force it in. Might break something important. Good thing I had an extra 3 Arduino boards. Plug in your power cable to the power supply. Then plug in your USB cable to your computer. You should see your computer recognize your Arduino board. Now load up the GUN4IR GUI. Go to Tools, then Flash Firmware. Select which player you want the gun to be and click Flash. OK. After the flashing process is complete, navigate to the Feedback tab and test out your recoil. In this next step, I'll be using some wire and a IR positioning camera. See links below. In this next step, you can either add some extra wire like I'm doing or just use wires from the camera. I would recommend using the same colored wires for this step. Strip the ends off of each wire. Now cut the wires off the end of your camera and strip each tip. Now splice each wire together. Let's solder each wire as well. You can either use electrical tape or shrink tubing for each wire. Now we can solder each wire to our Arduino board. See diagram for each location. I already have 2 wires soldered to my board from my solenoid. Solder the red wire to the VCC pinhole. For the ground wire, you can solder the wire to any ground pinhole. The yellow wire will go into the camera 2 pinhole. And finally, the green wire will go into the camera 3 pinhole. Solder each point. Now let's test out our camera. Plug in your micro USB cable into the Arduino board and then into your computer. Load up your GUN4IR GUI. If you need to flash your Arduino board, go to Tools, Flash Firmware. Select which player you want and then flash. Now go to the test screen tab. You should be able to move your camera around the screen. Now let's build the rumble pack portion of the build. Going to need a rumble motor, a 680 ohm resistor, a diode, 0.1 UF ceramic capacitor, a PN2222 transistor, and a PCB board. See links below. First, we will need to cut a 6x6 set of pinholes from the PCB board. Start with installing the ceramic capacitor. Install the capacitor into this location. Bend the leads back to lock the capacitor into place. Now let's install the diode. You will need to install the diode into this location. Make sure the gray bar on the diode is on the right hand side when installing. Just like before, make sure that to bend the leads back to lock the diode into place. Should look like this. Now let's install the transistor. When installing, make sure that the round side of the transistor is facing down and the flat side is facing up. Should look like this. Now let's finish with installing the 680 ohm resistor. You might need a pair of needle nose pliers to pull the leads through. Just like before, make sure to bend the leads back. Should look like this. Let's solder the leads onto the PCB board. Solder each point. When complete, clip the leads off. Should look like this when complete. Now strip the heads off 2 sets of wires. I would recommend red and black. Bend the wires to lock them in place. Solder each wire to the PCB board. Clip the leads when complete. Now we need to solder these points together with some solder. Let's solder on the red and black wires from your rumble pack into this PCB board. Place the black and red wire into this location. Will look like this when complete. Now we need to solder these points together with some solder. This is what it should look like when complete. Time to solder our VCC power pin wire. I'm going to use a yellow wire for this. Solder the yellow wire into this location. Clip the lead when complete and then solder these points together. Will look like this. Now it's time to solder the yellow wire to the VCC pin, the black wire to the any ground pin, and the red wire to the rumble motor pin. See diagram. If you already have a wire in the VCC location, you can either splice the wires together or solder the wire to the other side of the VCC pinhole. Now we can build the RGB LED portion of the build. We will need one 150 OEM resistor, two 100 OEM resistors, one RGB LED light, and one PCB board. Let's start with trimming up the PCB board. You should have 6x4 sets of holes. Make sure not to lose the piece you cut off. This is what it should look like. Now we can start installing all the parts. For the RGB LED, make sure to locate the ground pin. Should be the third and longest pin. Install the LED into the top set of the pinholes. Should look like this. Bend the leads back to lock the LED into place. Now we can install the two 100 OEM resistors for the blue and green sections. Insert the resistor into the correct pin ports. Do this for both resistors. should look like this. Time to install the 150 OEM resistor. You will need to install this resistor into this set of pinholes. Go through the same steps like before. Like before, make sure to bend the leads back to lock the resistors in. This is what it should look like. Now we can solder each lead. Make sure not to drink a handle of rum before attempting this, or I got the shakes. When complete, clip the excess leads. For the wire, I would recommend color coding each wire to the correct location on the PCB board. So from left to right, it should be blue, green, black, and then red. Insert each wire into the correct pinhole and bend them back to lock them in place. Flip the board over and solder each wire into place. Clip the excess wires when complete. Now it's time to solder the LED leads into the resistors and the resistors into the wires. This can be a pain in the ass, so take your time. You just need to connect each point with some solder. Should look like this when finished. Now it's time to solder the wires into the correct location on the Arduino board. Just follow the steps in this diagram. After soldering the wires onto the Arduino board, you should test out the LED to make sure it works. Quick tip: if you run out of ground pinhole spots on your Arduino board, you can either solder the ground wire to the back of one of your ground pinholes or splice the wires to another ground wire. When everything is connected to your Arduino board, plug in the USB power cable and load your GUN4IR GUI to test out each component. After testing, we can now start setting up our trigger A and B buttons. Let's cut 2 wires and strip the ends. I'm going to use white wires for my A and B buttons. Solder each wire to these locations on the Arduino board. Now we need 2 ground wires for the 2 buttons. I don't have the original buttons that came with this gun, so I'm going to use 2 push buttons. See link below. What's good about these buttons is that they fit perfectly in this gun con. See diagram for ground wires and signal wire locations for each button. Also see diagram for pinhole placement for the original buttons for the gun con. You can always change the button layout in the GUN4IR GUI later if you want to. Change the A button or the B button to another side of the gun. Now solder all the wires to each button. Now for the trigger, we will need a ground wire and a signal wire. Twist the wires together and solder. Then either use the shrink tubing or electrical tape on each wire. See diagram for solder locations on the Arduino board. So this will be the layout when installing all your components. Take your time at this point, or it can be a pain in the ass. I would start with the camera and work your way back. Before attaching the camera to the gun, make sure your camera is in the correct position. You will see a sticker on the camera that says top. This should be facing you. I would also verify with the GUN4IR GUI after installing the camera to make sure it lines up correctly. For the RGB LED, I used a soldering iron to melt a hole in the back of the gun and then hot glued it down. I moved my components around a few times to get everything to fit correctly. Hot glue the rumble motor down in the handle of the gun. For the recoil, I moved it to the front of the gun and hot glued it down. So every gun will be different when installing all the components. This was the final result of my GUN4IR build. After verifying all the components work one more time, close the shell of the gun and screw it back together. When everything is back together, plug in your GUN4IR into your computer and the power supply and open up your GUN4IR GUI. Go to the Screen and Camera tab and select Start Calibration. Calibrate your gun and exit. One side note, if you're using a gun con like mine, I would recommend purchasing a fisheye lens with a custom 3D printed adapter for your gun. You can pick this up from Raymond over at RPEG Electronics. See link below. Now it's time to shoot shit with your GUN4IR light gun, or now you're playing with power. Just remember to take your time with this build and everything should work correctly at the end. Also, if you don't feel like making your own GUN4IR, you can always reach out to Raymond from RPEG Electronics and he can build you a very professional GUN4IR build.
These are all the
If you like this video and want to see more, bring the hammer down on the like button, laser beam the subscribe button, and enchant the bell for future video notifications. Until next time, buckos, it's the Arcade Pirates sailing out.